Hello everyone. Today we're going to be talking about the quadratic formula. Now this is normally the last thing you learn in the quadratic chapter. So first of all, what is the quadratic formula and how do we use it? And when do we use it? So we know the formula to be x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now we use this to help us find the x-intercepts. X-intercepts are also known as your zeros, your roots. These are all basically synonymous terms to find the same thing. When we talk about the x-intercept, right, we had a video over here, you can take a look above, that the x-intercept is a coordinate, and it happens on the x-axis, and it happens when the y value is equal to 0. So when we talk about our a, b's, and c's for this formula, we see that based off of the standard form of a quadratic, where y equals to ax squared plus bx plus c, a is the coefficient for x squared, b is the coefficient for x, and c is just a constant in the back. In this scenario, we always figure out when y is equal to 0, so ideally 0 is equal to ax squared plus bx plus c. So now we are going to take a look at a couple of examples on how we use quadratic formula. So again, the quadratic formula is used to find our x-intercepts, roots, or zeros. So let's say we're given this function here, where y is equal to x squared minus 6x plus 5. Now normally, if you want to find the x-intercepts, so on and so forth, you can simply let the y equal to 0, and then we can take a look at this function one more time and see that we can probably factor it. So we're going to do this in both methods. We're going to factor first and solve, and then we're going to use the quadratic formula to see how we would run through it and get the same answers. So for this one here, if we think about how to factor, again, you can go through your steps, but you should get the answer where your two brackets will have x minus 5 and x minus 1. Then we mentioned that multiplicity rule says that if two things multiplied together is equal to 0, then one of the two things have to be 0. So what we do is we let each scenario, like this one, x minus 5 equal to 0, or x minus 1 equal to 0, and we solve. With algebra, we'll find out that x is equal to 5, or x is equal to 1. So again, x-intercepts, you can say that it happens at 5, 0 and 1, 0. But normally this is good enough to show where the x-intercepts would be. Now let's do this using the quadratic formula. So here, for the quadratic formula, we have a equaling to 1. Again, it is the coefficient of x squared. So if you don't see anything, it must be a 1. The b here is the coefficient of the x, so that becomes negative 6. And the c value is just the constant in this case, which is 5. So just to remind you what the formula is, again, it is x equals negative b plus or minus the square root of b squared minus 4ac, all of that, over 2a. So now all we need to do is plug in everything and see what comes out. So x equals negative b would be negative 6 plus or minus the square root of b squared. So for this one here, make sure to always put your b value in brackets. Minus 4, a is 1, c is 5, all over 2a. Now, you can probably put this in your calculator and get the answers right away. Otherwise, if you want to show your work to double check, ideally what I recommend is doing the following. So we've got double negative on 6, so that's positive 6 plus or minus. And ideally, you want to figure out what's in the square root. The bottom 2 times 1 is just 2. If we take our calculator here, underneath the square root, we have 36 minus 20, so that gives us 16. So this will help you check if you're doing this correctly. As we continue, we'll see here that x is equal to 6 plus or minus the square root of 16 is 4, and all that over 2. So now we see here that we get plus or minus in between. So how do we differentiate? Well, you can go, if I did x plus, that would be 6 plus 4 divided by 2, which is 10 over 2, which gives me the 5. If I went x minus, this would be 6 minus 4 all over 2. That would be 2 over 2, which gives me the 1. So as you can see, the answers would actually match exactly what we would do if we got the answer by factoring. Now let's try another example. So this one here, once again, we can see that we have a quadratic. Again, we need to let it equal to 0. So ideally, move the 4 to the left. Right? And to do that, you can subtract 4 from both sides, like so. And if we do that, we would end up getting 4b squared plus 8b plus 3 equal to 0. Again, we can factor this. So again, you can use bottoms up method. You can check out the video up above if you are not familiar with it. You can use any other factoring method you like, but bottoms up gives you a systematic way of doing it and a way to check if you've done it correctly. So for this one here, we're looking for two numbers where we multiply to give us 12. But when we add the two numbers, it gives us 8. So thinking about what two numbers would work here, and you should come up with 6 and 2. So you can see here 6 and 2 work for both conditions, so therefore we know these are the right numbers. Just to run through bottoms up one more time, bottoms up would say that I would go b in both brackets. One gets the plus 6, one gets the plus 2. Now the lead coefficient here was a 4, so I need to divide my numbers by that leading coefficient. So dividing both by 4, and then we're going to reduce the fractions as much as we can. So then we would get b plus 3 over 2 and b plus 1/2. Now here's where the bottoms up part occurs. Because we can't reduce the fractions anymore, we bring the denominators to the front, hence bottom up, bottom up. So your final answer would actually be 2b plus 3 and 2b plus 1 would equal to 0 once we have factored it properly. From here, we can basically, again, split both cases. So then we would get 2b plus 3 equal to 0, or 2b plus 1 equal to 0. Again, using algebra, you can solve, right? So you end up getting b equaling to negative 3 over 2, or b equaling to negative 1/2. Now you can see for questions like this, it is a bit more tedious, but you can still get the right answers. Now, let's try using the quadratic formula and seeing how that would differ in the process. Okay, so we have reset the question, and we can see here that once again, if we subtract 4 from both sides, we get to this part here, where the quadratic is equal to 0. Remember, this is the basic setup that you will need in order to use the quadratic formula. So for this one here, again, a is going to be 4, b is going to be 8, and c is going to be 3. So if we plug this into our quadratic formula, we would get that x is equal to negative b, which means negative 8, plus or minus the square root of b squared. Again, we'll bracket it just in case. We always put it in brackets, so then we don't mess up in case it was a negative number. So b squared minus 4, a is 4, and c is 3, all over 2a, which would be 2 times 4. Once again, we will simplify everything we can. So negative 8 plus or minus the square root of all over 8. So let's put this in our calculators and see what we would get. So 8 squared minus 4 times 3, we get 16 underneath the square root. And again, we can simplify. So that's going to be negative 8 plus or minus the square root of 16 is 4 all over 8. And now we can split apart our two answers. So x plus would be negative 8 plus 4 over 8, which is equal to negative 4 over 8, which reduces down to negative 1/2. And if we did the minus version, I would get negative 8 minus 4 over 8, which is negative 12 over 8. And if I reduce that, we get the negative 3 over 2 again. So potentially this is going to be faster for some, but this isn't the best use of quadratic formula. So let's take a look at one last example. With this one here, let's try and factor it first. So it's already set up as a quadratic equaling to 0. And let's see if we can figure out if we can factor this. If so, that's great, and we can get our answers pretty quick. But if we can't factor it, then you're kind of forced to use the quadratic formula. So let's see what happens. So again, I need two numbers that multiply to give me -6, but add to -7. All right, think about what two numbers can multiply to -6, but add to -7. I don't think it's possible. So you can think about all the combinations. Right? You got 6 and 1, -6, but then you get +1. So again, that doesn't work. So it doesn't look like factoring is going to be possible here. So in that case, we have to scrap the idea of trying to factor, and therefore we need to use quadratic formula to get to the right answers. So let's remove this, and let's try using the quadratic formula. A is 2, B is -7, and C is -3. So that would tell us that x is equal to -7 plus or minus the square root of -7 in brackets squared minus 4 times a, which is 2, times c, which is -3, all over 2a. All right, let's try and simplify this. So that would be 7 plus or minus the square root of all over 4. Again, put this in your calculators. Don't forget for the brackets of the -7. Minus 4 times 2 times -3. And I'm getting 73 on the inside. Now, if you realize root 73 is a prime number, so we can't really simplify it any further. So therefore, our two answers are just going to be x plus, would tell me it would be 7 plus root 73 all over 4. Now, you could change this to a decimal, but then you might have rounding errors. So it just depends on what the question wants. So normally we keep it in terms of a fraction and radical format, since it's most accurate. X minus, in this case, would just be 7 minus root 73 all over 4. So here you would end up getting your two answers. And just a reminder, inside the square root, right, that is called the discriminant. And again, you can watch a video here where we talk about the discriminant. The discriminant tells you about the nature of the roots, whether there's going to be 2 or 1 or none, right? So again, if inside is a positive number, like we have right here, which is positive 73, we're going to expect we're going to have a plus and minus answer come out, like so. If underneath the square root was a 0, then you just get the one answer, because if you plus or minus 0, it's the same thing, no difference. And lastly, if underneath the square root is a negative number, we know that there's a restriction that you cannot square root negative numbers. So that would tell you that you would have no x-intercepts or no roots. I hope that summarizes everything you need to know about the quadratic formula. Again, it is useful, but ideally factoring is the most important method first. If factoring fails, then you have to default to using the quadratic formula to look for the roots, because sometimes they'll turn out like this, and there's no way that you'd be able to factor to get these kind of answers. Make sure to like the video if you found it useful, and share with your friends if they're having trouble with this concept of knowing when and how to use it. Please subscribe to the channel and keep following us with our current math videos. We'll be posting more in the future. So again, keep increasing your math knowledge, and I'll see you guys in the next video. Bye.